to Module 2.3. In this lecture video, I'm going to show you a couple or three examples solving application problems involving with fractions. So this one is a little bit translation. I think we've done something similar to this in Module 1. Let's take a look. The product of two numbers is 15 over 2. If one number is 45 over 7, what would the other one be? So something times something, is 15 over 2. If one of the number is 45 over 7, what would the other one be? So it's just almost like saying, a number times somebody is a product, and then telling you what one number is. So to find the other one, we will have to divide. The question is who divided by who? Well, it's actually got to be the product. Okay, let me just do this let me just kind of write like this. Let me not use a fraction, let me use a whole number. If something times something is equal to 15, and one number is 3, the other one got to be 5. Most of us kind of know that. But algebraically, to find this question mark, to find this number, we know we had to do the opposite operation, which is dividing. So when we divide, we got to take the 15, which is the product, divided by what's that one number. So in our case, we have to take the product and divide it by, doing it backwards, right? It was multiplication to come up with 15 over 2. Now backwards would be taking the product divided by that one fraction, 45 over 7, okay, in order to find out what the other fraction or number is. So division of a fraction means times the reciprocal. So that will be times by 7 over 45. I know 7 and 2 cannot be reduced, but 15 and 45 can be reduced by 5. That will give me a 3 and a 9. Well, that tells you now I can reduce them by 3 again. So that means I could have reduced 15 and 45 by 15 itself, which is 1 and 3. So 1 times 7, that's it. No more things can reduce. 1 times 7 is 7 over 2 times 3 is 6. Okay, so remember, it's always easier to reduce top and bottom when we multiply first as compared to multiply first and reduce. Always reduce first before you multiply. All right, this example, an airplane carrying 180 passengers, which is 9/10 of the capacity. Okay, so this plane can actually carry more than 180 passengers. So, which is 9/10. So the 9/10 is the 180 passengers. What is the capacity of the plane? So we are looking for the total. Okay. We cannot take 180 times by 9 over 10. That does not make any sense, because that means we are saying 180 is the total number of passenger can fit on this plane. As a matter of fact, this plane can actually carry more than 180, because the problem says the 9/10 of the capacity is that 180. All right. So what is the capacity of the plane? So in this problem, we actually need to take 180 divided by 9 over 10, because we're looking for the total this time. All right, so when I divide it by 9 over 10, the 180 means 180 over 1 times the reciprocal, which is 10 over 9. So 9 and 180 reduce into 1 and 20, and 20 times 10 on the numerator tell me I can actually hold 200 passengers. Okay, I can actually hold 200 passengers total. So the 9/10 is the 180 passenger. So the other 10th, or 1 over 10, is 20. Okay, 1/10 is actually going to be 20 other passengers. Okay. All right, very strange problem where we have to divide. Now this problem is a little bit weird. There's a lot of things going on here. So it says 3,200 students at Lake High School, Lake High School, and 3/8 of these students are sophomore. So 3/8 out of 32 are sophomore. If 3/5 of the sophomore, oh Lord. Okay, 3/8 of the total is sophomore. If 3/8 of the sophomore in favor of forming a crew team, and 7/10 of the remaining students, not the sophomore, are also in favor of forming a crew team, how many students are opposed? Oh gosh, that's a lot of things going on. Are opposed to this idea. Okay, so let's just back it up. Let's just figure one thing at a time. So 3/8 are sophomore. So 3,200 total, right? This is the total. 3/8 of the total are sophomore. So we times by 3/8. 3/8 of the total. Now 3,200 times 3/8 means 3,200 over 1. 8 and 3,200 reduced into 1 and 400. 400 times 3, 1,200. So 1,200 students are sophomore. So not sophomore. Not sophomore got to be the total 32 minus 1,200, which is 2,000 students. Okay, are not sophomore. If 3/5 of the sophomore, 3/5 are the 3/5 of sophomore are favor forming a crew team. So how many sophomore are not? 3/5 favor. 3/5 favor. 3/5 of the sophomore favor. That means the other 2/5 of the sophomore not favored. All right. So sophomore is 1,200 students. 2/5 of it. So that means times by 2/5 does not favor. So this number here tells me how many sophomore does not favor forming the crew team. So 1,200 means over 1. Let's reduce 5 with 1,200. Let me divide here on the side. So 5 going to 12 two times, that's a 10. 2, bring down to 0, that's 4. 1 more 0, so that will be 240 not favor. Actually not favored. Not flavor. Did I roll flavor? Favor. Oh goodness. All right. So 240 sophomore not favored. And 7/10 of the remaining students. Okay, so think about this. Remember now, I had 1,200 sophomore and 2,000 are not sophomore. So 7/10 of the remaining 2,000 students also favor the crew team. So if 7/10 of the remaining student body favors, then the other 3/10 does not favor. So where is this 2/5 come from? Where does 3/10 come from? Well, the 3/5 and the 2/5 together makes a whole, and that whole representing the entire sophomore students. 7/10 of the remaining student is favoring the crew team, so the other 3/10, because 7/10 plus 3/10 makes another whole, and that whole is referring to the 2,000 students that are not sophomore. So 3/10 does not favor it. So 3/10 of the remaining not sophomore, so that will be 2,000 times 3/10 does not favor. So 2,000 means 2,000 over 1. So let's see how many students. 10 and 2,000 reduced, that will be 200. 200 times 3 is 600. So there are 600 students that are not sophomore, does not favor having a crew team. So how many student total that is not favored? That will be the 600. Okay. Of that are not sophomore plus the 240 sophomore that does not favor. So my answer 840 students does not favor forming a crew team. Okay. So just a quick 3 examples on applications regarding to fractions. That will conclude this lecture video. Thank you for watching.